This video presentation is going to be over calculating the dosage in pounds when given a percent purity. As always, I do not own any of the questions or material presented in this video, as it was all sourced off the open internet. I have, to the best of my knowledge, presented the proper formulas and the correct answers, as this is a study guide and for educational purposes. If it helps you learn, that's great. Here we have the Davidson pie chart, also known as the pounds formula. I pulled this off the state of Florida's formula sheet. If you have seen any of my other videos, you will know that I always suggest that if your state provides a formula sheet when taking the exam, that you should find a copy and use it while practicing math. If you haven't already done this, come on, man or woman. When using the Davidson pie chart, to find the quantity above the horizontal line, pounds per day chemical feed 100% purity, you're going to multiply the three pie wedges below the line together. So the flow mgd times the dose milligrams per liter times 8.34 pounds per gallon. When you multiply those together, you will get the feed rate pounds per day as 100% pure. If it is not 100% pure, you are going to divide the pounds 100% pure by the purity as a decimal. The given units must match the units shown in the pie wheel, so million gallons a day, mgd, and milligrams per liter. Also note that the dose is interchangeable between milligrams per liter or parts per million. Here's our first question. How many pounds of 65% HTH would be needed to dose 5 million gallons at 50 milligrams per liter? As a practice, I like to pull the known and unknowns out of word problems. That way it's easy to keep track of the values. So what we know is that we have 5 million gallons. We want a dose of 50 milligrams per liter, and the percent purity is 65%. What we don't know is the pounds needed. The unknown will always give you the formula you need to solve. Here we have the feed rate pounds per day formula, dosage milligrams per liter times flow mgd times 8.34 pounds per gallon divided by percent purity as a decimal. Notice our units of measurement do not match because 5 million gallons is not mgd. Believe it or not, 1 mg is equal to 1 million. Who would have thought? For practice, I will write this out so we can do unit conversions. Remember, the units you want gone always go on the bottom. You want them dead, you're burying it. It goes underneath. So in this case, we're going to do division. So you're going to have 5 million gallons times 1 mg over a million gallons. So you're going to end up doing division so that the gallons cancel out, and you're going to get 5 mg. Now that we have everything in the correct units of measurement, we plug it into our formula. So 50 milligrams per liter times 5 mg times 8.34 pounds divided by the purity percentage as a decimal. So first let's do the multiplication on top. When you do the multiplication, you end up with 2085. So now we're going to divide that by 0.65. And the answer is 3,207.692. We're just going to go ahead and round to 3,207.7. One thing to take note when you do this, if you have a less purity, so it's not 100%, after you do the division, the number should get bigger because if it's not 100%, you're going to need more. So remember that when doing percent purity problems. When you do the division, you're going to end up with more pounds than when you started before the division. If a storage tank holds 1 million gallons filled to the overflow and the initial chlorine dose needs to be 15 milligrams per liter, how many pounds of HTH, 65% available chlorine, will it take to get the required dose? First, let's pull our known and our unknowns out of our word problem. You have a volume of 1 million gallons. The dose is 15 milligrams per liter. The percent purity is 65%. And we're looking for the pounds required. Here we go. Pounds per day, dosage milligrams per liter, times flow mgd, times 8.34 pounds per gallon, divided by the percent purity as a decimal. So we're going to need to convert the volume of 1 million gallons into mg, so it can go into our formula. Remember, what you want gone goes on the bottom, so it cancels out. So 1 million times 1 mg over a million gallons. Gallons will cancel out. And you're left with 1 mg. So now we can plug this into our formula. 15 milligrams per liter times 1 mg times 8.34 pounds per gallon divided by the percent purity is a decimal, so 0.65. We're going to go ahead and do the math on the top first, which gives you 125.1. So now we're going to divide by 0.65, and your answer is 192.46. We're going to round that to 192.5, and again, you should end up with more pounds of the less percent purity stuff, right? So the 192.5 is bigger than the number we started with, and we're good to go. The 50,000 gallon storage tank is disinfected with 50 milligrams per liter using HTH. How many pounds of HTH, 65% available chlorine, would be required? First, we're going to pull out our known and our unknowns. So what you know is you have 50,000 gallons, a dosage of 50 milligrams per liter, the percent purity is 65%, and we're looking still for the pounds required. Here again is our pounds formula, dosage milligrams per liter times flow mgd, or just million gallons, times 8.34 pounds per gallon, divided by the percent purity as a decimal. Like most math problems that you have to do in water, you got to convert stuff. So let's get 50,000 gallons into mgd. I know I keep saying mgd because that's what the formula is, but it can just be million gallons. So 50,000 gallons times 1 mg over a million gallons. The gallons will cancel out, and you're left with 0.05 mg. So now we can plug all of our stuff into the formula because we have the correct units of measurement. So 50 milligrams per liter times 0.05 mg times 8.34 pounds per gallon. We're going to divide that by the percent purity as a decimal, so 0.65. Again, solve for the math on top. So you have 20.85 divided by 0.65. And the answer is 32.07. I'm just going to round that to 32 pounds per day. A small tank containing 1,500 gallons of water needs to be disinfected in order to be put back in service. If the dosage needed is 35 milligrams per liter, how many pounds of calcium hypochlorite, 60.5% available chlorine, are required? First, pull your known and your unknown out of your word problem. What you know is you have a volume of 1,500 gallons. A dose of 35 milligrams per liter, the percent purity is 60.5%, and again, we're looking for the pounds required. If you hadn't guessed from the title of this video, yes, we're still using the same formula. These are all the same. So again, being the same, gallons need to be converted to mgd, so we have the same units of measurement. So you have 1,500 gallons times 1 mg over a million gallons. You're going to do division. That's going to give you 0.0015 mg. Now that we have the correct units of measurement, we can plug all that into our formula. So you have a dose of 35 milligrams per liter times the volume of 0.0015 mg times 8.34 pounds per gallon. Again, you're dividing by the percent purity as a decimal, so 0.605. We're going to solve the math on top first, and you get 0.43785. You're going to divide that by 0.605. And the answer is 0.7237 blah blah. Just round it to 0.72 pounds. You want another math problem? Well, too bad. I'm tired and I'm done with this presentation. So instead of 5 questions, you're going to get 4 questions on how to solve pounds of chemical when given percent purity. Hopefully this video helps you learn. Thanks.